Hello students, myself Mohit Pandey. In this video, I will explain you derivation of electric potential due to an electric dipole at a point due to an electric dipole at axial position. So, in this video, I will explain you. Please understand that I will explain you derivation of electric potential at a point due to electric dipole at axial position. Understand? So you can see in this diagram, AB is an electric dipole where plus Q charge is kept at point A and minus Q charge is kept point B, and the dipole length of AB is 12, and at point P where electric potential is to be determined from the distance of R from the center of dipole. You can see here, you can write the statement: consider an electric dipole consisting of two charges plus Q and minus Q charge, which the dipole length, that is the distance of AB, is 12, and the dipole is placed in a medium of dielectric constant K. We have to find the potential at point P. We have to find the potential at point P is studied at distance R from the center of dipole. And now we potential at P due to plus Q charge. Potential at point P, इस पॉइंट P पर हम लोग देखेंगे कि इस पॉइंट P पर इस चार्ज प्लस Q की वजह से जो पोटेंशियल होगा, द पोटेंशियल इज रिप्रेजेंटेड बाय V1, and V1 is equal to 1 upon 4 pi epsilon naught K into Q by AP. You can see here the distance of AP. Okay, so V1 is equal to 1 upon 4 pi epsilon naught K into Q upon AP, and V1 is equal to 1 upon 4 pi epsilon naught K into Q by R minus L, because AP is equal to OP minus OA, and you can see also the distance is AP. But the distance R is taken from O. So AP is equal to OP. OP में से हम इस OA को इतना माइनस कर देंगे, इस पूरे OP में से इस OA को माइनस करना है, तो बचेगा क्या? ओनली ऑन OA, that means that is 12. You know OA 1L and OB 1L. So R minus 1L becomes AP, you know, R minus L. So V1 is equal to 1 upon 4 pi epsilon naught K into Q by R minus L. It is the equation number first. Potential at P due to minus Q charge. Now, due to minus Q charge, the potential at point P is represented by V2, and V2 is equal to 1 upon 4 pi epsilon naught K into minus Q by Vp. Understand? So V2 is equal to 1 upon 4 pi epsilon naught K into minus Q upon R plus L. Since Vp is equal to OP plus OB, you can see here OBP, and the distance from center of the dipole O is R and we have to add OB, and the OB, the value of OB is L. So we have L plus R, that is B to P, L plus R, and we can write 1 V2 is equal to 1 upon 4 epsilon naught K into minus Q by R plus L. There says Vp is equal to OP plus OV, and this is the equation number 2. Therefore, since potential is a scalar quantity, potential is a scalar quantity, so the resultant potential at point P, V is equal to, now this is V1, this is V2, but we have to find the resultant potential. What is the total potential at point P due to minus Q charge and due to plus Q charge? So the resultant potential V is equal to V1 plus V2, and V is equal to, from equation first and second, V is equal to V1 plus V2 and 1 upon 4 pi epsilon naught K into Q by R minus L plus 1 into minus Q by 4 pi epsilon naught into K into R plus L, and we find total potential, you can see here, is V is equal to, we have 1 upon 4 pi epsilon naught K and Q as common. So we take common Q upon 4 pi epsilon naught into K into V in the bracket 1 upon R plus L, sorry, R minus L, and plus minus 1 upon R minus L, understand, is equal to, you can see here, R minus L and R plus L. So Q upon 4 pi epsilon naught K into, it is the LCM of R minus L and R plus L, R minus L into R plus L. So R minus L, so R minus L cancel, and the 1 is multiplied by R plus L, and plus into minus, so minus 1, and 1 is multiplied by R minus L, understand, you know, this is equal to Q upon 4 pi epsilon naught K into R plus L, minus into plus minus R, and minus into minus into minus plus L upon A minus B to A plus B is equal to A square minus B square. So R square minus L square, understand, and Q upon 4 pi epsilon naught K into 1R and plus 1R minus 1R is cancelled to each other. We have to L upon R square minus L square, understand. So we have, you can see this, under V is equal to 1 upon 4 pi epsilon naught K into Q multiplied by 12 upon R square minus L square, understand, and V is equal to Q into 12. The electric dipole moment, you can understand, the electric dipole moment P is equal to Q into 12. So Q into 12 is equal to 1 upon 4 pi epsilon naught into K, understand, and P by R square minus L square, understand, and volt. This is is equal to P electric dipole moment. Understand? This is for air or vacuum. Air or vacuum. K is equal to 1. Air or vacuum, K is equal to 1. Therefore, from equation number third, V is equal to 1 upon 4 pi epsilon naught into P by R square minus L square. Understand? Volt. This is equation number 4. This is required expression. This is required expression of electric potential. Electric potential at axial position. Understand? So now special case. Understand? So please take a special case. So we have special case. Special case is if first if L, if R is greater than L, then L can be neglected. L can be neglected, and from equation number third, we have V is equal to 1 upon 4 pi epsilon naught into K by P upon R square volt. Understand? That is equation number 5. If the distance of point P where the electric dipole is to be found, when the distance of the required point is to be larger than the dipole length, then L can be neglected, and we have V is equal to 1 upon 4 pi epsilon K into P by R square volt for air or vacuum. K is equal to 1. So from equation number 5, V is equal to 1 upon 4 pi epsilon naught into P by R square volt. Understand? Equation number 6. This is also required expression of electric potential. Understand? Thanks for watching my YouTube channel. Please subscribe my YouTube channel. If you like my video, so please comment on comment box. Thank you very much.